staggering amount. So today, we are very happy to have esteemed professionals to share their technologies on plastic waste resource recycling. They are respectively from academia, industry, as well as research institute. They are from both Indonesia and Taiwan. So before we have our first speaker, I would like to invite Professor Liu Zhicheng, the Director of the Science and Technology Innovation Center on Circular Economy and Green Innovative Resources, to give us some words. Let's welcome Professor Liu.
Thank you very much, Professor Yo. Okay. Good morning and selamat pagi. Okay. I understand that this is the Ramadan for all the Muslim friends. So I'd like to wish all Muslim friends, particularly those in Indonesia, have a peaceful, bountiful, holy Ramadan, which is full of love, joy, and gratitude. We are very honored to have several distinguished speakers joining our webinar today. First of all, of course, let's welcome Director Woma Dewanti of the Sustainable Environment Research Center of ITS. I would also like to take this opportunity to congratulate Professor Woma Dewanti for her promotion as full professor. So I'm really proud and happy for her. Okay. In the meantime, we are also honored to have project manager Mr. Wu Binrong from Jian University Environmental Engineering Corporation, and also Deputy Division Director Dr. Amy Huang Shuquan from ITRI, as we know that ITRI is the most prestigious institute in Taiwan. And last but not the least, okay, we also welcome Professor Guan Wenhui, my old friend from Minzhi University, to share with us her knowledges and specialties on plastic waste. Okay. As we know that plastic waste will cause some serious issues. Okay. So I think today is only the starting point for us to get to know something about the technological aspect of plastic waste. I hope that in the near future, we can also sit down and learn from each other about how to manage plastic and how can we minimize the use of plastic. I wish our webinar this morning, very short, very concise, but very successful. Thank you very much for coming. Thank you.
Thank you. Thank you, Professor Liu. With the Science and Technology Innovation Center, we look forward to having more successful collaboration between Indonesia and Taiwan. So before we start our exciting presentations, we would like to invite all of you to have a group picture together. So please turn on your video if that's available, okay?
We are going to take a picture together, so participants who are able to turn on the video, please turn on the video. We take a short time for taking picture. Please, Mbak Tia, Mbak Bella, please help us later to take a screenshot of our event. Yeah? Mbak Tia, can you count so that we get ready for taking picture? Okay.
For the next page, 3, 2, 1. Okay. Finish.
Okay. Thank you, everyone. Followed by Professor Liu's introduction, the first speaker will be Dr. Wama. She is from Sapulong November Institute of Technology, Indonesia. She is a member of the Laboratory of Solid and Hazardous Waste at the Department of Environmental Engineering. She is also the head of the Research Center for Infrastructure and Sustainable Environment. Most of Dr. Warma's work are with solid waste management in Indonesia, including the closing the loop of plastic waste in Surabaya, Indonesia, and that's in collaboration with UN Economic and Social Commission for Asia and Pacific, Institute for Global Environmental Strategies, Japan, and the Surabaya city government. Today, she will talk about the current status of plastic waste recycling in Indonesia. So please join me in welcome Professor Warma.
Thank you. Good morning. Thank you very much, Dr. Yu. So hope that next month I can meet with you in Taipei and together with Professor Liu. Thank you very much, Professor Liu. And also, I think the speakers, we know that we have Mr. Wu and Professor Huang and Professor Kwan from many different backgrounds and from the academics and also from the practical point of view. So today actually is my great honor to present some of our research of the study about the current status of the plastic waste in Indonesia, especially about the waste management, because we really hope that in future, like Professor Yu mentions, that we can enhance the collaboration between Taiwan and Indonesia, how we can recycling of our plastic, because the type of the plastic in Indonesia maybe will be different with another country. So I will share my screen about the plastic waste management in Indonesia. Can you see the slide already?
Yes.
Yes.
So, okay, this is about the plastic waste management in Indonesia and the current status. Okay, and then we already, this is a little bit introduction about me. Then Professor Yu already mentioned that right now, I still have the research, especially about the building a local sustainable supply chain in recyclable material, especially for plastic waste for medium city in Southeast Asia with UK. And also, we also work with some of our partners, especially about analysis of the material flow of the plastic waste in Indonesia. And then if we can take a look based on these figures, this is the figures that takes in 2017 from CEGIR et al., that plastic is a very useful material, and we can know that mostly plastic used as a packaging. And since 1950, this is we can show from the production process that plastic at that time, the production only 2 million metric tons, but then increased remarkable in 2015 to become 322 metric ton. And based on these figures also, we can see here that only 9% of the plastic that recycled, and the others is dumped in the landfill, or they are treated with the thermal process such as incinerator, pyrolysis, and also gasification. And then if we take a look, this is the plastic waste generation worldwide, and we can see Asia mostly contribute to 51% of the global plastic production. And then the country with the biggest plastic polluter is always changed time by time, because we know that many of researchers right now really interested in this kind of the topic, because we know the effect of the plastic waste in the ocean, in our environment is a lot. So it's why then the country's biggest plastic polluter right now may be already changed. And then based on this, how about in Indonesia? Indonesia, we total inhabited about 277 millions of the people in 2023. We are the biggest of archipelago country around the world, and we consist more than 17,000 of islands. And based on the data, the plastic industry is one of the sectors with significant contribution to the manufacturing output in Indonesia. And over past 10 years, plastic production output has ranked number 5 in the national level after basic metal, motor vehicles, chemicals, and food. And we can see based on this figure also that the consumption of the plastic in Indonesia is quite high. We can see from this figure actually, this is from Ministry data actually, but put in the DRE Pulse Checks data in 2023. We can see from here that the import of the plastic to Indonesia is a lot. Okay, and then the trade balance is mostly negative. And based on the Ministry of Industry in Indonesia, they mentions that in 2019, the consumption of the plastic in Indonesia per person per year is around 19.8 kilogram, but then increase in 2020 to become 22.5 kilogram per person per year. So we can see the increasing of consumption of the plastic in Indonesia. And then based on the plastic consumption also, 34.8% mostly used as a packaging. So it's very similar what we show from the first slide that mostly the plastic will be used as a packaging. And others, especially like a plastic bag, is around 32.26% in Indonesia. Other than that, automotive and building and electronic. So the biggest one is plastic packaging, especially. Then in Indonesia itself, if we take a look from the waste management, because we talk about the waste management, so it's wide, and I would like to share a little bit with our friends in Taiwan, especially and other country, that the waste management in Indonesia is really different because from the sources like a residential area, this is responsible of the local community that manage of their waste. Then they will have to transfer to the central point, one of the central point, or we call it transfer facility, or we call it in Indonesia is TPS. Then from the TPS, they will go to the landfill site. And then from others facility like a street, market, and commercial, they will be also transferred to central point or transfer facility. Then after that, they will be transported to the landfill site. But some of them maybe will be transferred to landfill directly for final disposal. So this is mostly the waste management, including plastic mostly will be like this one, because in Indonesia, we are mix all of our waste. So really rarely that we are separate of waste at the sources. That's why then mostly will be dumped in the landfill site. And this is waste generation and composition. So this is in general. So in general, about the solid waste production in Indonesia or generation in Indonesia, we can see increase from 94 million tons per year in 2018 to become 90.8 million tons per year in 2020. And based on the composition also, the composition changed a lot. Previously in 2018, based on the World Bank data, that mostly the plastic waste in Indonesia only 13%. But right now we can see this is, for example, in one big city of Indonesia in Surabaya, where I live and also where the IT is located, the plastic waste is around 22%. So it's why then we can see that increasing the composition of the plastic in terms of composition of the waste in Indonesia. Then, based on the plastic waste generation also, this is analysis from National Plastic Action Partnership in Indonesia in 2019. Based on the data in 2017, the NAP is analysis that around plastic waste generation in Indonesia around 9.8 million tons per year and growing by 5% annually. We can see from here that mostly Java Island is really a lot because they show here that the highest one is the colors is around like a little bit red, pink or something like this one, and the lowest one is the green one. And we can see here the Java produce a lot of the plastic waste compared to another islands in Indonesia. Then, based on this data also, we can see this is the fate of the plastic waste in Indonesia, just only 10% that recycling, then 20% managed disposal, and then other than 9% is official dump site, and the others is a lot is open burning and dumping in the land and also leakage into the sea, lakes, or the river. So it's why then, based on this data, we can see that we still have a lot of mismanagement of waste, especially regarding to the plastic waste in Indonesia. And this is some of the summary that we have, okay? But the most important thing on the recycling of the plastic in Indonesia is the informal sector, that including waste picker, junk shop, and also aggregator. They collect around 500,000 tons of the plastic waste directly, especially from the residential area, because the waste pickers usually will come from door to any houses in Indonesia, and then they try to collect of the plastic waste. And 560,000 tons of the plastic collected from the landfill site or from the collection point, like we call it the TPS. And again, based on the data on NPA also, they mentioned that 1 million ton of the plastic that collect by the informal sector, just only 700,000 tons transport to the recycling of plastic, but the rest it will be lost because of some of the yield losses. So during the process, so it's why then around 300 tons eventually disposed due to yield losses. And then Indonesia plastic recycling rate is based on this data is around 10% that we have mentioned previously. Okay. And this is, for example, we are conduct the research also in the level of the city, mostly will be very similar with the national level. For example, this is in Surabaya, mostly the plastic waste that produce around 1,100 tons of the plastic waste, okay, generated per year. So then 74% will be retained at the landfill, just only 11.3 that recycling, and still open burning, and then retains on the land, and marine litter is also a lot in Surabaya city. This is example in our research project. Then how about the plastic waste composition? Again, this is based on the data of Surabaya, and mostly will be very similar with the area in Java, because based on the plastic waste composition, a lot is the plastic bag. You can see from here, especially for single-use plastic bag. And then the other is sanitary product, okay, and the others is single-use food surfaces. And then other than that is also drink bottles. So this is the plastic waste composition. And the plastic waste composition that released to the environment, again, the biggest one is plastic bag. And then the others is like a single-use food surfaces. And then sanitary product and drink bottle is also released to the environment. Okay. And based on this composition, we really hope that we can learn from Taiwan how to recycling of plastic waste, especially for non-valuable one. Because in Indonesia, actually for valuable one, we already like a PET and HDPE, we already recycling this one. But for low valuable of plastic, we still have a big problem. And we are also not yet implemented the packaging standard in Indonesia. So then it will be more challenging for the recycling of plastic, because the type of plastic is really a lot and in Indonesia. And then based on this data, also we can see about the recycling of the waste in Indonesia, mostly conducted by the informal sector, either for the waste bank, central waste bank, and then recycling enterprises that already mentioned previously. We have like a waste picker, aggregator, small scale recycling enterprises, large scale recycling enterprises. They work a lot to recycling of the plastic, especially for the valuable one. And then this is the data from the Unilever. The Unilever already have some of the research regarding about the plastic waste and then past customer of recycling in Indonesia, especially. We can see from here that the total plastic consumption in Indonesia, this is based on the data in 2020, 5.6 million tons per year. Then virgin domestic capacity, this is for the plastic production. This is around 2.3 million tons per year. And we still import of the plastic, as we are mentioned in the previous slide. We have virgin import of the plastic around 1.67 million ton. And this is the recycling capacity. The recycling capacity based on the Ministry of Industry for the plastic is 1.65 million ton. But again, we can see from here about the post consumer recycling. We can see only 0.32 million tons per year. So we can see a lot of substantial gap indicated how recycled plastic are poorly managed in Indonesia right now. PCR itself, we know that this is the environmental friendly packaging option that made from recycling of plastic, like from PET or SDPE. But in here, the capacity in Java only 0.32 million tons per year. So we can see here very low compared to the recycling of capacity. And we already know also, based on the data, that mostly the plastic that used in Indonesia is for packaging. So it's why then in Indonesia right now, the government tried to increase the recycling of the plastic from the packaging. And we can see from here, we have a lot of regulation regarding waste and regarding of the plastic waste itself, we have a lot of regulation. One of them that is very popular is about the Indonesian plan for the action to combat the marine plastic debris, okay? Because in Indonesia, we are known that one of the polluter of the ocean is come from Indonesia, especially for the plastic waste. So it's why then the government tried to reduce the plastic marine debris by 70% in 2025. And this is the main pillar. One is the biggest one is how to behavior change of the community and reduction of land-based leakage, reduction of sea-based leakage, and reduction of plastic production and use, and also enhance of the mechanism for funding and work together with other countries, for example, and also implementation of law and regulation in Indonesia. And based on the recycling plastic packaging itself, because this is a huge number, and then we are also produce a huge number of the plastic packaging waste, okay? And we can see from here right now, recycling of plastic packaging is part of the circular economy in Indonesia. And this is already put in one of our national agenda, how we can enhance the circular economy, especially also for the plastic waste. And then this is also the regulation that already support actually is why then right now some of industry already care about the extended producer responsibility, how they can manage of their waste after consumed by the community. One of them that work together with us, later on I will be show you, one of the that work together with us try to collect of their waste especially, and this is based on our data. Usually for the waste recycling, as we are mentioned in Indonesia, we depend on the informal sector. This is the data from Surabaya itself, how the waste bank involved and how the small scale enterprises involved in collecting of waste, including of the plastic. And then as we are mentioned right now, we also have the collaboration with one of the company. We try to enhance the extended producer responsibility and circular economy implementation by non-helicans concept that brought by the Coca-Cola Pacific partner that involve also, as we have mentioned, the waste bank and informal sector to collect of their plastic waste actually. So based on this one, we hope that the plastic packaging especially can collect it more and can recycling more in Indonesia. This is what we also conduct the research regarding informal recycling sector, because this is, as I mentioned, is very important. Right now, we try to have the opportunity to integrate the informal recycling sector into municipal solid waste management, because in another country like Brazil and any South American country, they are very successful to integrating of their informal recycling sector to the municipal solid waste management. So hope that can enhance the recycling of the plastic waste. This is some of the example. I'm sorry, this is maybe too small, but we can see from the national action plan of the plastic in Indonesia, some of the activity already conducted, especially how we can enhance the recycling and involve of the community on recycling of the plastic itself. And this is also the action plan that already have by the Surabaya city government. Medium-term objective will be try to enhance the recycling, of course, by some of the technology to recycling, to increase the recycling capacity especially, and long-term objective also similar. And then we will be build the open access database of the plastic waste management, okay, because it can accommodate supply and demand of the plastic waste recycling. And this is the last of my presentation. We really hope that we can enhance the collaboration with Taiwan and other partners, how we can mapping the plastic and plastic waste from potential industry. This is especially as part of the circular economy and implementation of extended production responsibility in Indonesia. And the social science, how we can enhance the participation of the stakeholder in managing of plastic waste. Technology, as I mentioned previously, because we just know right now about the technology, the recycling of valuable plastic waste, but for low valuable plastic waste like plastic films and others, we still don't have any recycling process right now. And technology to monitoring of release of the plastic waste to the ocean, because as mentioned that we are one of the contributor of the plastic waste in the ocean. And build the database for plastic waste management to accommodate the supply chain on the plastic. So we would like to enhance the number of the plastic recycling that can be used as a product. And of course, the last one is effective of extended production responsibility. So thank you very much. This is the end of my talk. I would like to give back to Professor Yu. Thank you.
Okay, thank you. Thank you, Dr. Wama. Do we have any question from audience?
Perhaps
Okay.
I would like to raise a question, Dr. Yu, while
Yeah.
we are waiting for other participants to raise their questions. I'd like to open a little bit discussion. My question to Professor Wawa, may I?
Yeah, sure.
Yeah, Professor Wawa, based on your presentation, we can see that somehow Indonesia rely on for the plastic waste management, especially for the recycling part, we rely on informal sector. Informal sector here is playing a very important role. In the future, are we still going to rely on the informal sector for this part, or is it better to push more on the formal or government role in this case? What is your opinion?
Yeah. For especially for this one is actually is like a 50-50 to answer about this one. Because as we know that the informal sector, especially in developing country like us and also in some of developing country, they contribute a lot, and they already know actually where the plastic will be go, and then how they can choose which one that has a high valuable of value of the plastic. As I mentioned previously, in some of the country, they already can integrate the informal sector to the formal, like we call it the formal sector of the waste recycling. Like we are mentioned in Brazil, some of my friends in South America, also usually they are very successful to integrate this one. So I hope in the future we also can integrate this one in Indonesia, especially because they are known very well how to manage these kinds of the plastic recycling. And then we also can contribute actually from the academic point of view and also from the government point of view, how to recycling. It's mean that clean recycling, because right now almost all of the informal sector, okay, they still don't have any good technology in recycling, and then it still contribute to environmental pollution in some of the area. So it's why then the integration between formal and informal sector in the future, we really hope that can be built in Indonesia especially.
Thank you. Thank you very much. For other participants, you are welcome to raise your hand for further question, or you can just type your a question through the chat box we have. And then later we are going to discuss. I think by the end of this session, we are still going to have other time for discussion, right, Dr. Yu?
Yes, correct.
Mm.
Okay, so again, do we have any question from audience? Let me see if they, okay, not yet. Okay, it's okay. For those participants, you have questions, you may just leave your question on the chat board, and then we will return to your question later before the end of the this webinar. So if there is no questions currently, that's thank you to Dr. Wama for her exciting talk. Thank you.
Thank you, Dr. Yu.
Okay, so our next speaker is Mr. Wu Pinjun, and he's from Jiean Environmental Engineering. And the company was founded in Taichung in 1980 as a plastic pelletizing plant. Later, it expanded to include waste recycling. The company is committed to environmental stewardship, adhering to the government regulations to transform industrial waste into reusable resources. The company aims to establish a circular recycling system for waste composite plastic, promoting environmental sustainability and resources conservation. So let's welcome Mr. Wu for his talk, Circular Recycling of Waste Composite Plastic.
Hello, dear host, dear all participants in Indonesia and Taiwan. It's a great honor today to have this presenting opportunity. So can I share my slides, right?
Yeah, please. Thank you.
Okay. From the beginning, I'm Wu. I'm from Jiean Environmental Engineering Company. Today, I would like to talk about the recycling plastics industry in Taiwan. It's a brief concept presenting. So the first paragraph will talk about the revolution of soft plastics packaging in Taiwan. From the left to the right, we can see from the 1957, the Taiwanese manufacturer import the plastic packaging material from Japan, which called CPP. The next, from the 1960 to 1970, the manufacturers began use large quantity of OPP. It's different type of the material from Japan, and start printing various labels on OPP packaging films. It's suitable for printing to attract consumers. The 1980 to 1990, the composite packaging material is getting more and more popular. In response to the function for food preservation, the medical material protection packaging, and the other needs. From the beginning of the 1990s, it is marked the peak period for the use of the composite materials. The last one is from the 2000 until now, the material packaging appeared. The metal packaging material, especially the aluminum plastic films, they offer the superior functionality, providing protection for the technology product during the same period. This kind of material is deposable. The quick packing solution sweep the whole market. The next page, we can see the overall of the recycling rate through the different periods. You can see the more than 95% of the recycling, the waste, we use the recycling just to produce the pellets, and less than 5% we do it by the refining. From the 1960 to 1970, the recycling situation is changed because the labels, the printing, the chemicals on the outside of the surface of the packaging. So the recycling, the pellet is getting fewer because it's more difficult to handle it, and the refining is getting bigger. From the 1980 to 1990, we can see the incineration. The first incineration plants in Taiwan was appeared. So this part of participant is getting bigger. The 2000s until now, because getting more and more difficult to handling the hybrid material of plastics. So we can see many others handling waste appear in Taiwan. The SIF, the incineration is still getting bigger, and others. The next page is talking about our company, the history of Jian. From the 1970, we start to recycle and to reproduce the pellets. And by the 1994 is our formal establishment date in Taiwan. We commenced the environmental protection business in Taiwan. The 2007, the established Laisen. Laisen is a Japanese company in Mingu, specializing in local factory packaging, recycling, and we trading the material from Japan to Taiwan. In 2008, because it's a mutual business model, we established a recycle organization in Taiwan, and we also serve the Japanese founding company setting up factory in Taiwan to plan recycling program. In 2012, we commenced the on-site service. We put employees on customers' factory, especially in technology industry, because their waste is very complicated. So we have our crew in there. We obtained the ISO 9001 in 2015 and the ISO 14001 also at the same year. And you can see we also developed a cloud-based weighting scale system. In 2020, we know is COVID-19 is a disaster for the human activities from all areas. So we start to obtain many certificates and the permission. You can see the Class A waste deposit permit, the TUV, the PCR, and the GIS. We all got here. In 2021, we also, sorry. At this year, we try to obtain a goal of closed loop recycling. I think it's more significant because more and more customers need more demand than handling waste, the traditional way to handling waste. So we can collecting, we can help them to sorting and reproducing, and finally we can produce to the finished goods and sell it back to customers. It's a concept of closed loop recycling in here. We since, as mentioned before, we since 1994, our employees more than 120, and we have our vehicles more than 20 to serve our customers. The business location in Taiwan, we have more, four, actually is 4 right now, maybe will be 5 next year. In middle of Taiwan, Taichung, Miaoli, and Kaohsiung. And in Japan, we have actually right now is 2 business location in Japan. What we serve here, you can see we reproduce the pellets from the recycling waste, and we are recycling organization, Class 8. We also provide the on-site service to our technology customers. Of course, other industry if they are needed, we will also provide. It depends. And the last one is environmental production. As I mentioned, we can also, you see a t-shirt here, a t-shirt image here, picture. We use PET tray. We don't use PET bottle because PET bottle is very mature material to produce the clothes, but we use PET tray we're collecting from the technology industry. What we serve here, and you can see we have our collaboration partners. We have TSMC, AUO, and Mitsubishi, and Micron, and many Taiwan and former company. Yes, you can see here. What kind of industry we serve? The ratio is, you can see the majority is technology industry, food industry, food packaging industry, and we have automobile related industry as well, and others. The on-site service, as I say before, because we have different demand from different kind of industry, which means different challenges. So I think IT and the technology industry is the most difficult one. So we provide the smart on-site recycling service to them. We collecting, we sorting, we do every process. We try to use the technology way and to provide the data to both parties. It will be easier for our customer and our factory to handle and manage. The on-site services, you can see the process flow. The first is the employee, they try to sorting. And the second one, they try to squeeze the extra space for the waste. The third, sorting and storage, because if we handle the waste in a good way, we can minimize the storage space, and we can have more efforts, good efforts in a production line. Now that's one, centralized transportation. Yeah, is a part of transportation way to use the truck. You can see a video here. We try to waiting. Use our system. We put labels and scan. Use the personal badge, personal ID card to upload all the picture data and all information on the surface of the bag. We also use the QR code. It's more easier to checking immediately. So we can see all the data online and on their mobile. We can check all the information, delivery, details. It's also the handling processes at the Taiwanese famous hypermarket. from the beginning to the end, you can collecting, sorting, and reproducing into the recycling pellets. The last picture, as you see. The processing flow here, you can see the videos. We try to remove some unnecessary material from the raw material. And the second videos, cut it into the right size and try to break into the pieces and make into the pellets. And the fifth video is try to dehydrate. And the last one is try to package it. The next paragraph, recycling technology. As mentioned before, we produce the recycling pellets, but right now customers need to get more and more difficult and more complex. So we got a GRS certification to meet customers' demands. It's a global certification to checking the sources and the process from this kind of material. The aluminum plastic separation equipment is a significant part and innovation in our company, because the founder of our company, he invents this kind of machine, because the traditional way to handling the aluminum and the plastic foam was using the chemical way. Is costly, and the carbon footage is getting more and more, and the influence for the company image is bad. So our owner, he invents this machine, try to separate this kind of different hybrid material by the physical way. Okay, you can see the workflow from the left to the right, the operation panel, the transport ship, the crucial, the produce, the output will divide into two parts, the aluminum strip and the plastics. The environmentally friendly products. This is a collaboration from the top to the bottom. We create a recycling supply chain for our customer and from our supply. You can see the AUO here is our customer. We're collecting their waste, and we cooperate with the ITRI, and they provide some consultant and some advice and some methods to us, and we're collecting and do all the processing in the middle of the supply chain, and we sell the finished product to our customer again, but it's a different one. You can see it's from our material to produce into the keyboard. Application of the recycling aluminum, plastic foam, raw material. You can see many kind of different packaging, and the raw material here we can make into such as the panel, the starter panel, bicycle panels, the plastics sheets, and the aluminum cords. Here, the pellets. Okay, the clothings for the technology industry, the garbage bag here, and the casual wear. We're using, as I mentioned before, we're using the PET tray. Certifications and the awards, we got some licenses. We have some collaboration activities with the government and the non-government organizations. Okay, it's all I presenting today. So if you have more questions, we can discuss later. Okay, thank you.
Thank you, Mr. Wu, for your exciting presentation. Do we have any question from audience?
Dr. Yu, we have several questions written on the chat box. I summarize here. There are 3 questions. Perhaps we can discuss one by one.
Oh, yeah,
Okay,
sure. Thank you. That's helpful. So, hi. So first question we have from audience. Indeed, that's from me. Okay.
Okay.
Because when I read your, when you present, you present that you are able to collect and sort your plastic waste. I mean, what kind of plastic waste they are you can deal with? Are they all plastic bags or other materials, other kind of plastic waste can be dealt with by you?
Okay. Basically, we collecting, I think it's majority of the waste from the, because we're collecting the PIR mostly. PCR part of, but not our majority of our business model. What kind of plastics waste we're collecting? We're collecting PP material, PE, PET, ABS, PC, PC ABS, a lot, PS, AS, all kind of materials. But we only do the pallets in our factory in PP, PE, and EPE, EPEP, such as just like if ABS, PC, this kind of material, we will sorting and collecting, filtering. We will sell it to others factory to do the recycling pallets.
Okay, and then the pallets will be applied to generate or to produce the t-shirts. I mean, the other products, right?
Yes.
Okay, I see. Thank you. So we have another questions, which is from Mr. Brett. Okay, and he mentions that how do you sorting different plastic by manpower or by any equipment?
Okay. So wait a minute.
Yeah, sure.
Okay. I think it's a big topic to discuss because manpower and the equipment both we are needed. The traditional way to separate, we use water density. We use water density because the more than zero under the zero, we can separate into the PPPE, and the others will be heavier. The density will be higher, so we can use the water density method to separate some part of the material. But the manpower, I think, is in my opinion, I think it's more important than the equipment because the material, the inside of the material is getting more complex. So the experienced employees are very treasured to us to separate the hybrid material, just like I mentioned before, the aluminum, plastics, this kind of material. The outside is very easier to tell. It's very different kind of material, but just like a PE, PP, and PS, we need we need experienced employees to help us to have more specific way to do the sorting.
Yeah. So followed by this question, do you have? I mean, does Jiean has the equipment for sorting materials for sorting different plastic?
Sorting.
Yeah, because I mean, do you have any equipment for sorting plastic in your company?
Excuse me, it's the third question, right? It's the third one, or
Or that's still the second question. I mean,
okay, it's okay.
yeah, because you mentioned that by both manpower and equipment, these two approaches matters.
Yes.
So I'm wondering, do you have any equipment in your company that can be applied for sorting different plastic?
Yes, yes. But I think the equipment is necessary, but I mentioned before, I think the manpower is more important for my opinion. So
Okay.
yes.
So you collect the waste plastic from your customer,
Yes.
and then you sort these plastic waste by your company, right?
Yes.
Okay.
All by
I see.
ourselves, and we try to distinguish into the different category. We reproduce the recycling pallets, and but only some part of pallets we reproducing in our factory. We don't do all the material reproducing in the factory.
I see. Okay. Thank you. Let's see if we have another question. Irving, could you please?
Question from audience, Mr. Abiyu raised his hand. Perhaps he wants to ask question directly.
Yeah,
Okay,
thank you, Bu
please.
Ervin. Hello, Mister. My name is Harmich, and I'm from Institute Technology School November, and I want to uh, say something about your presentation. That in Indonesia there are several reasons why Indonesian people do not sort the waste. The one is they want to sort the waste, but there are no and sort the waste. And the three, they feel it is not their responsibility to sort the waste. Some people even admit that they had stopped sorting the waste because it had already been sorted, but the mixed again by the officers. This is our reflection on in the reflects that there are imbalance between awareness of waste sorting and if I want to ask your opinion, what is more suitable system to replace the existing waste management system to support the creation of zero waste condition that are systematic, measurable, and comprehensive and sustainable? And is there any suggestion from non-government participant to the Indonesian government? Thank you, sir.
Hello, Mr. Wu, you there?
Sorry, the significant was weak, so I tried to figure out our friend from Indonesia. He was asking, so wait 1 minute. Okay, I'm back. I think the plastics is impossible to disappear. So it's very necessary for our daily life, whatever in our daily activities or in the industries, because it's very convenient. So government and the non-government, the normal people, they try many efforts. All of us, we try many efforts, including the disposable, the material as a company's representatives. We try to collecting the. I think the sorting collecting is a primary way to dealing with this problem first. But the government's policy is also very necessary to combine the efforts from the government and the non-governments. So it's make efforts by everyone. So we need time.
Okay, thank you, sir.
Thank you, Mr. Wu. I think we are a little bit delayed for our schedule, but it's fine. Despite we still have couple of questions to Mr. Wu, and
Yes.
I think we can leave them later. I mean,
Okay.
yeah.
So we are going to discuss this at the end of the event, right? We are going to continue to the next speaker, but we
Yes,
still
yes.
have several questions that we are going to discuss by the end of this, after every presenter already presented. Is that correct, Dr. Yu?
Yes, correct.
Okay. Mr. Wu still have homework to do. We still have questions for you, what we will discuss later.
No problem. Thank you.
Okay, so thank you, Mr. Wu. So our third speaker is Dr. Huang Shujian Amy, and she is the Deputy Division Director of the Chemical Engineering Division at ITRI, Industrial Technology Research Institute in Taiwan. As some of you may know, ITRI plays a critical role in developing innovative process in Taiwan. ITRI is also the bridge between academia and industry, which makes the laboratory invention to the industrial process. Dr. Huang, she is an expert in nanomaterials, polymer composite, and catalyst. She holds a PhD in chemical engineering from Pennsylvania State University. She is doing groundbreaking work on chemical recycling technology for waste plastic. Now let's welcome Dr. Huang for her talk, The Development of Chemical Recycling Technology for Waste Plastic in ITRI.
Okay, thank you, Dr. Yu. Is my voice clear for everyone?
Yeah, it's clear.
Yes,
Okay,
yes.
great.
Yes,
Hello,
yes.
everyone. I'm Amy Huang. I'm from ITRI, and thanks to Dr. Yu's introduction. And I think I will just skip this because ITRI is the largest international applied research institute, and we have a headquarters in Hsinchu. And actually, my lab, the materials and chemical engineering laboratories, is also located in Hsinchu. And we also have several offices around the world. And since our founded in 1973, we already have more than 300 spin-offs and startups. And we also cooperate not only the companies in Taiwan, but also we collaborate several international companies around the world. And in ITRI, we have the budget about half from the government funding, and about half we come from the technical service to the local companies and some international companies. And as Dr. Yu said, that we serve as the linkage between the academia and the industry. So the technology readiness level, we typically work with a TIL4 to TIL7, which is the pilot scale. And then I think the industry can adopt our technology and to commercialize it. So I will go back to our main topics right now, I think the recent climate data indicates that 70% of the climate change are coming directly from the extracted fossil carbon from the ground. And for all the plastics and the chemicals that we use every day, they are about 90% is coming from the fossil-based carbon source. So even we have the energy transformation, we still need these carbon because the materials already have the carbon embedded inside. So in order to reach the net zero in the future, we need to have a new carbon source. That is, for example, there's a report from the Nova Institute. They reported that to 2050, maybe all the if we don't use the carbon coming from the fossil fuel, then we can transform this carbon to about 55% coming from the recycling, 25% from the CCU, CO2 based, and 20% from the bio-based. That is, recycling is a very important strategy to resolve these CO2 issues. Today, I will talk more about the chemical recycling strategy because the mechanical recycling is quite mature technology in Taiwan, and the quality of the recycled plastics typically determines the recycling strategy. And for the more single stream and clean plastics and thermoplastics, you can use mechanical recycling method to recycle the plastics, but this is the less energy is required for mechanical recycling, but the product is typically not virgin grade. So if you use this packaging, for example, for the milk container, and then they will become the, for example, for the toolbox or bucket, the recycled product. But for the more complicated plastics and have more impurity inside, we will use chemical recycling method to recycle these kind of plastics. And there are two kinds of plastics we are talking about. One is condensation polymers. The condensation polymers is like PET, PU, polycarbonate, and nylon. They are composed with two different monomers, and we can use depolymerization method to depolymerize these kind of plastics back into the monomers. And there are the addition polymers. The addition polymers is like PP, PE, and PS. Although it is thermoplastics, we cannot use the depolymerization methods such as the transesterification or hydrolysis method to depolymerize these kind of polymers. Instead, we will use the pyrolysis or gasification to break down those carbon-carbon bond. So for the mixed plastics like PPP, PS, we also work on the pyrolysis method to gain the plastic oil and go back to the naphtha grade. And right now, we have the project from the from Taiwanese government, and this is from the MOEA, which is the Ministry of Economic Affairs. And we already developed several chemical recycling technology to work on the PET and PU and PC. And right now we are working on those more complicated plastic, those mixed plastics such as PPP and PS mixtures. So first I will introduce our technology for the PET chemical recycling. In Taiwan, we recycle about 100 kilotons of PET bottles each year with a recycling rate about 95%. However, these PET bottles, we can also classify into two kinds. One is a clear bottle, which is a transparent one. And right now they are used for the PET fibers or to bottle recycling. And this is quite mature in Taiwan's polyester companies. And the second one is those with the green bottles, the soil bottles, and the tray and packaging, and those with mixed colors. And these are the lower grade of the PET bottles. So right now they use for the staple fiber and for the fillers and some packaging materials. But this one, if you want to upgrade their recycled product, you can also go through the chemical recycling technology to depolymerize back to their monomer grade. And for the PET textiles, right now, half of the PET textile collected in Taiwan are export to other countries, but also half of them are going to the incineration. So there's a need to solve the contaminant mixed PET waste and also for the textiles. And that's why we developed the chemical recycling technology. And for the chemical recycling technology for the PET, typically there are 3 different types of methods. One is the hydrolysis, the second one is the methanolysis, and the third one is glycolysis. And for the hydrolysis, we use water as a depolymerization agent, and typically we have an alkaline inside. And with methanolysis, we use methanol, and glycolysis typically is EG. EG is also a monomer for the PET. But the drawbacks, each of the method have their drawbacks and their benefits. But for the hydrolysis, it forms salt during the process. So it's difficult to separate their resulting depolymerous products such as TPA from the salts. And of course, they can form the TPA directly just by the hydrolysis. But the drawback is the purification of the TPA. And the second process is the methanolysis, and the DMT, which is the ester form of the TPA, is typically formed first. And the benefits of DMT is that it is easily purified by distillation. But right now, the commercial plant of the polyester company, they don't use DMT because during the polymerization, methanol is released, and they don't want to use methanol in their plant. So typically, if you depolymerize into DMT, you have to transform to either TPA or BHET. BHET is actually the TPA and EG after the esterification. And glycolysis will use EG as a depolymerization agent, and their product is called BHET. And the great thing of BHET is it's more easier to purify, and we can use the crystallization method to purify the product. That's why we choose glycolysis method to chemical recycled PET. And in Italy, we developed the technology, the whole process to recycle the PET textile as well as the packaging. So I would use textile as an example because the textile is typically the most difficult one to recycle. And we developed a heterogeneous catalysis system. And then the feature of this technology is that there's a very low metal leaching and high efficiency that we will have. We only use minimum amount of EG to depolymerize the PET, because we know that the economic is one of the big issue for chemical recycling. So if we use the less EG, that means that the EG loss will be minimized, and we can have a more economic process. And the second one is we have a good technology to remove the dye effectively. So it's very important because we want to have excuse me. Oh, okay. We want to use the virgin grade of the monomers. So it's very important to remove the dyes. And then for the whole process, if you want to have a lower carbon footprint, the thermal integration of the whole process is also very important. So after we calculate our process, if we compared the chemical recycled PET and the PET waste, they were treated, the end of life is incineration. The carbon footprint can be reduced to 60% when you use the chemical recycled PET. And in ITRI, we have developed this pilot scale chemical recycling process coming from the waste PET fabrics is sorted. We obtain these PET fabrics from the local polyester company. And then we have the pilot scale recycling instruments in ITRI. Right now, we can do the glycolysis and dye removal in our pilot plant. And then we obtain the polymer grade BHET, which is a very high purity. And also it's the yellow index is very low, it's less than 2. And then we use this monomer and then we repolymerize back to PET. And this PET is like a virgin grade. So we also demonstrated for the fibers, fiber to fiber, and also to the fabrics. So I will show you the, okay, it's not working. Sorry. Okay. Is this working or not?
It's not working yet,
Not
but I
working.
think you can switch your pointer to arrow. So
Oh, okay.
yeah, so you can click that.
How do I use it? Oh, okay. Yes.
Yeah, okay, that works.
Great. So this is the fabrics feed inside, and then this is the depolymerization process. And then after that, the products was coming out. And we use crystallization and recrystallization method to purify these monomers. And these are after polymerization, we can have this PET pellet. And then there's a spinning process. And then after extinction, we have the unwinding, we can get the PET fibers. And this is 100% recycled PET from fabrics. And we also make some knitting and to make the fabrics and the clothes, a t-shirt, coming out of the recycled fabrics. Okay. So next one, I will talk about polyurethane. And polyurethane is mostly, I think we use it in a seat or sofa and furniture. So, but because it's porous and it's very bulky, so we need to develop the recycling method for the polyurethane because it is right now in Taiwan's incinerator, they don't want to deal with the polyurethane because the heat value is too high. They can normally it will damage our furnaces. So in typical, there are also 3 methods to recycle the polyurethane. And traditional glycolysis method, they typically have various byproducts and it's difficult to reuse. So in ITRI, we develop a new method, and we don't depolymerize these polyurethane to their monomer stage, or we instead we depolymerize this to become the oligomer or a very small colloid dispersed in the polyols. And polyol is actually the raw materials for polyurethane. So we disperse this recycled polyurethane, and then we can reuse this kind of mixture back to the polyurethane form. Right now, the source of the polyurethane waste can be the bike seat and the sofa and the bed. Okay, so after depolymerization, and we can proceed the formulation of the polyurethane. And the formulation is also important because you want to have the high quality of the recycled polyurethane. So right now we can have a compatible properties to virgin PU forms. And we can also formulate it to make high resilience foams, which is the more valuable products for furniture with recycled content up to 20%. So they have the similar density with the version 1, and also the rebound is also have the similar quality for the version PU foam. So again, I will show you the some slides. So these are the PU foam scrap we obtained from a local company. And then we depolymerize it. And these are the products coming from it. And you can see these are very small PU colloid dispersed in the polyol. And this is the process for making the PU foam. And after that, we can make the sofa out of it. So this sofa is actually right now in our in E3, in the lobby of E3. Okay. And that's when I will talk about more complicated plastics. We know the PE and PP are the most common packaging plastics we used. And however, typically these for the plastic bags or plastic packaging, they are more contaminated and cannot be separated. So right now, we will use the pyrolysis method. In Taiwan, we also have a plastic pyrolysis plant that will be able to pyrolyze these PP and PE mixtures. And for this kind of waste, you will go through a NIR pre-sorting system. So typically, in these mixtures, they are at least 90% of the waste is composed of PP or PE. And after the pyrolysis, we obtain the pyrolysis oil. But the pyrolysis oil cannot be directly used to the chemical industry because the pyrolysis oil is typically very dirty. So we need to develop an upgrading process in order to transform this pyrolysis oil to naphtha. We know that naphtha is the basic ingredient that we can go through the cracking. After steam cracking, we can obtain the basic chemical compounds inside. And after that, you can just input to the existing chemical industry value chain. So this is our current project right now. We know that it's the pyrolysis oil is typically very dirty. It has several impurities inside. And also after pyrolysis, you have the pyrolysis oil actually contains a lot of unsaturated bond. So it is not the great, this kind of oil, we cannot put it directly into our naphtha steam cracker. Because in naphtha steam cracker, not only the impurities is less than 100, it's about 1,000 ppm, less than 1,000 ppm. Also, there are very few unsaturated bond. So in order to transform the pyrolysis oil to naphtha grade, right now we are developing the catalytic process, including the hydrogenation, hydrotreating, and hydrocracking. And after these three upgrading process, we can obtain this kind of naphtha. And then it can be used as a naphtha substitute. But it is right now. It's also a developing project right now. So we are also forming some industry alliances between the plastic pyrolysis plant and the local petrochemical industry in order to develop a new value chain for plastics. Okay, so I will conclude my talk I think the chemical recycling is gaining more and more important. This is because the limited plastics are available for mechanical recycling. However, the economic process is also very important to industrial realization. And in E3, we already developed a pilot scale fiber to fiber or foam to foam process that can recycle the more dirty PET or PU forms. And waste plastic to naphtha is our new project. It will deal with the dirty and mixed polyolefins. And it is also very important to meet the growing demand for recycled feedstocks. And I will thank you for your attention. And any question is welcome. Thank you.
Thank you, Dr. Huang, for her exciting talk and a lot of sharing. Okay. Do we have any questions from audience?
I think we have question in the chat box, but before we proceed to that question, can I ask, I like to confirm one thing, if I may.
Okay.
Dr. Huang,
Yes.
yeah. So it seems like different type of polymer will require different kind of technology to do the chemical recycling, right?
Yes.
How about the raw material? You mentioned that this technology is also applicable even for dirty plastic waste. It doesn't have to be clean.
Mm-hmm.
Is it correct?
Yes. Actually, normally the chemical the materials for chemical recycling, we don't need to clean it, but we need to pre-sort it. For example, PET, we still want it to have that at least 80% of purity of the PET, because it's from the economic point of view. Because if you have, for example, the waste content is only 50%, then of course your yield of your product will be lower, and then you will waste a lot of energy just to purify all the impurities. So the pre-sorting technology is also important. Actually, in Taiwan, but in E3, we also developed the sorting technology that I didn't present today, but we have like NIR sorting, Raman sorting, and several other spectrometry using several technology that can separate this plastic waste.
Okay, thank you. Then let me share a screen for the next question. Wait, allow me to share my screen. This is the next question, Dr. Yu.
Yeah, yes. I think we have one more question from the chat board, and he's asking about the market and the price of the pyrolysis products. Can that be reviewed?
Okay. Actually, right now, the plastic pyrolysis product is not so common in Taiwan right now because the market is not so good, because we are still working on the upgrading technology that could make the pyrolysis products more valuable. But currently, these pyrolysis products, because they have impurities and also the composition is not correct for the naphtha substitute, they are typically used as a fuel, and that's why the price is actually not so high. As I know that it's probably around 10 to 20 NT dollars per kilogram.
Okay, I see. Yeah, I think that. Thank you. I think with I mean, after the product is more valuable, and the price will go high for sure.
Right.
Yeah, because currently you are just use that as a fuel.
Right.
Yes. Thank you. Okay. Thank you
We have one more question from audience. One audience raised hand.
Really? Okay, let me check. Raise.
Mr. Abiyu Armin.
Yeah.
You have question?
Yeah,
Please, you
but
can, yes.
uh,
Boleh silakan.
thank you, Miss. I want to ask something. After the process previously explained, can recycled raw material be converted into the biopolymers or mixtures that are more environmentally friendly? That I think there has been a decline in the quality of them. Thank you.
Sorry, I didn't hear your question quite clear. So it's you mean the quality of the recycled
Yeah.
plastic?
So the the recycled feedstock, the recycled feedstock, uh, can it uh can it be converted into biopolymers or mixtures?
Okay. For the feedstock, for example, for PET, right now it's all from the petrol-based. But if it is from bio-based, it's also okay. The bio-based can also go through the chemical recycling method. And of course, the quality of the feedstock is also very important. That's why we need a pre-sorting procedure to at least get like 80 or 90% pure of the plastic that we want to use. Sorry, maybe I didn't answer your question correctly, but if you want, you can write it down because I think the signal is not so clear.
Okay.
Okay.
Okay. Thank you, Dr. Huang and Mr. Avery. Okay. So, for the audience, if you still have questions, please you can just put them on the chat board, and we will return to your question later. Okay. And now we are welcoming our first speaker. Okay, Dr. Wang Wenhui, and she is an esteemed professor in the Department of Safety, Health, and Environmental Engineering at Minzhi University of Technology. Dr. Guan Shi is also a leading expert in the fields of resources recycling and waste management, process waste reduction and wastewater treatment, and the water recycling technologies. Her innovative research has contributed significantly to the developing sustainable technologies that promote environmental protection and resources conservation. So now let's welcome Dr. Guan for her talk, Recovery of Waste Polarizing Film Using Microwave-Induced Pyrolysis.
Okay, is my voice clear?
Yes, it's clear.
And you also can see my screen, right?
Yes, correct.
Okay, thanks. So good morning, everyone. I'd like to thank Vice President Professor Liu and Professor Yu for having me. Today, I'm going to address the research results of my lab on recovery of waste polarizing film using microwave-induced pyrolysis. My talk maybe slightly have some relationship with Dr. Huang, the previous speakers, because they use the pyrolysis also in recycling of the plastic. However, in my lab, we developed another kind of in lab scale microwave-induced pyrolysis. Ahead of my address, I'm going to use some time to introduce myself and the university that I work for. I'm currently a professor in Minzhi University of Technology. Meantime, I also act as several environment-related national committee member, such as Environmental Impact Assessment Review, research grant on area of environmental engineering for National Science and Technology Council, and the committee member of Cleaning Production Technique Mark for Industrial Development Bureau of Ministry of Economy Affairs. My research interests including developing of non-thermal plasma technology for some persistent pollutants treatment. Then I also try to reuse and recycling the waste using our developed microwave-induced reaction, that what I will talk today, and the cleaner production in high-tech industrial. Minji University of Technology belongs to the Formosa Plastic Group, FPG. As you see, our university belongs to a very big plastic corporation. And the founder of FPG is Mr. Wang Yongqing. He's very well known as his management tactics. So people call him Taiwan's God of management. Because Minji is an enterprise university, we focus on practice-oriented education since its establishment in 1963. And the research direction of Minji also aims to elevate both the quality and the quantity of techniques through cooperation with the industrialists. Now let's move on to the outline of my talk. First, I'm going to introduce the source and the characteristics of polarizing film and the progress of the film treatment that happened in Taiwan. Second, I'm going to address the microwave-induced pyrolysis, also called MIP, against the conventional pyrolysis. Here, my group has developed the MIP system and hold several patents about its extended research. Then I will present results and discussion regarding the polarizing film recovery. And my group also applied the MIP to precious material recovery using the MIP. So I'd like to share some of the results. Finally, I will give the conclusion of my talk today. As you know, there are many sorts of plastic, where the 7 groups, such as PE, PET, PP, account for about 92% of the plastic ever generated annually. Almost all our daily life needs plastic, from packaging, household leisure, sports goods, etc. Among them, electrical and electronic facility accounts for about 60% of the plastic consumption. Polarizing film is one of the products made of plastic. The polarizing film is also used for lots of electronic and electrical production. For example, the LCD, screen, TV, pad, mobile phone, laptop, and the sunglasses you wear on the sun day. In Taiwan, about 20 tons of scraps generated from the polarizing film manufactured annually. And most of the scrap were subjected to the incineration. However, because the iodine contained in the film, the purple plume emitted from the incinerator's chimney, that pollution happened in many counties and incinerators of Taiwan and have been widely reported in media. Here is the composition configuration of polarizing film. It consists of PET, CTA, PVA, EVA, and iodide. Among them, PET belongs to plastic, PVA, EVA are polymer, As you can see, they are all precious materials. Present, the scrap of polarizing film were crushed firstly and into small fragments and then sold to steel plants in mainland China for use as fuel. Otherwise, a small amount of polarizing film was mixed with other waste, such as household trash, embalmed and then incinerated. However, we are looking for some innovative approach to total recovery of waste polarizing film. Traditionally, the conventional heating system heat the object through thermal conduction mechanism. So the heat was from outside conducted into the inner of the object, and the heating rate is relatively low. In contrast, the microwave heating is molecular heating. The temperature in object sample in object center increases quickly. According to the interaction feature of material with microwave, we can categorize material into 3 types. The red curve indicates the energy absorbed per unit volume by the object. The blue curve displays the penetration depth of microwave into the object. So the category 1 is low power loss, and the microwave can almost totally travel through it. For category 2 material, microwave is partially lossy and partially penetrate the object, like water. As to category 3 material, microwave is no lossy and can't penetrate the object and almost totally reflect. So, apply the microwave to a material heating, we can choose different material feature with the microwave to enhance or induce specific chemical reaction. So first, we measure the dielectric property of polarizing film and utilize the absorbing microwave feature of the film. We can pyrolyze the film under microwave radiation and converted the film into solid, liquid, and gaseous product to achieve total recovery. In order to sophisticated manipulate reaction, we develop a microwave induced pyrolysis system. Here is the microwave power supply part, including magnetron, adjustment of reflection, and the water cooling circulation. And here is the main pyrolysis functional component. We can use different material of the sample holder to control the microwave penetrate or absorbing properties to achieve different reaction and obtain different ratio of our product. And here is the carrier gas system. We can adjust different gas from inert gas like nitrogen, argon to slightly active gas, for instance, steam or air or different ratio of oxygen. Then we can manipulate the reaction under as desired. And here is through the condenser, the product of the reaction can be gathered using the tar collector or gas collector. Then the solid residue remained in the sample holder. Liquid, gaseous product can be analyzed separately. So if we introduce the waste polarizing film into our MIP system, the solid feedstocks can be converted into fuel gas, such as hydrogen, methane, carbon oxide. Interesting things is herein. There is no carbon dioxide produced from the microwave pyrolysis. In addition, the iodide can be gathered in liquid or adsorbed on adsorbent, won't leak into the gas if you utilize suitable reactor types and dosing some adsorbent into the reactor. Now, let's look at the liquid product. Here are the composition configuration of the polarizing film. After microwave-induced pyrolysis, the benzoic acid and the phenol were generated. These two products account for about 60% of the liquid product. They are the basic ingredient of the original molecular for PET and the CTA in polarizing film. So the results indicated that this method could successfully decompose the polarizing film into original chemical resource. And the solid residual in the sample holder also can serve as an adsorbent for dye containing wastewater treatment. It has the type 4 property of porous material and the PET surface area of about 580 square meter per gram. Now, I'm going to extend the application of our MIP system to other waste recycling. The first case is a carbon fiber composite waste. Carbon fiber composite has been used in many current products, including bike, gas barrel, carcass, aircraft, and wind turbine blades, with lots of advantages, such as a high stiffness, high tensile strength, low weight. Its market grows fast with time. This slide shows that my lab have tested sample waste of carbon fiber composite. Currently in Taiwan, waste carbon fiber composite are burning in incinerator. It's just like throw money into burner, so we try to recycle the carbon fiber from the waste composite. After treatment, the recycled carbon fiber has very good qualities. This is the original waste bike cushion. After microwave selective pyrolysis, the carbon fiber and the glass fiber can be totally separated, and the tensile strength of the recycled carbon fiber can be remained about 90% compared to the virgin carbon fiber, and almost no impurity on the fiber surface. The application of the MIP to the carbon fiber composite is workable. And the second case of our MIP application is about the precious element recovery. In the past time, people take resources from a classic mine in mountain or wide field, but lots of the resources like trace metal have been used in every mobile phone computer. This precious element become very important. Also in the trade world, it's a very important card. Therefore, we have to take the resources from the urban electronic and the electric waste. This slide shows our second extended case that we applied our MIP system to waste recycling. First, we disassembled the spent lithium-ion battery, crush them all components and screen them for the black powder collection. Then we put the black powder into our MIP system for selective pyrolysis. And after microwave-induced pyrolysis, the lithium cobalt can be converted and separately recovered for pure lithium carbonate and cobalt metal and carbon powder. So it can just recycle to the original material for lithium-ion battery manufacture. Okay, I'd like to conclude my talk today. So the West polarizing film can be converted into gaseous fuel, chemical compounds, and char as a solvent using the microwave-induced pyrolysis system, and incorporating optimal conditions, cost-effective and sustainable recycling recovery of energy and resources from more plastic waste will be investigated in the future. Okay, that's my talk. Thanks for your attention.
Hi, thank you, Professor Guan. Do we have any questions from audience?
I think I have one question before we go to other participants' question. May I, Dr. Yu?
Yeah, sure.
Yes. Professor Kwan, yeah, it's very interesting talk. Thank you very much. I have one or two questions actually regarding to the technology that you applied, and I apologize if my question is quite basic. What do you think is the advantages of using the microwave-induced pyrolysis technology compared to the conventional one? Is there any advantages, or it still serves some drawbacks compared to the more conventional one? And also, I noticed that you use adsorber in the application. What is the function of this adsorber? Yes, those two are my question for now.
Okay, thanks, Professor Wawa, right?
It's Erwin.
Oh, Erwin. Oh,
Yeah.
actually. The first question about the advantage of microwave-induced pyrolysis against conventional pyrolysis, because the microwave is molecular heating. It's a kind of selective heating. Not all the material could apply the microwave-induced pyrolysis because some material have the microwave specific feature. They can absorb microwave, so you can create a local hot spot in the bulky or material or waste. And so the temperature elevating is very fast in microwave-induced pyrolysis. However, in conventional pyrolysis, you just use the convection of thermal, right? So the temperature increasing from outside of the object into the center of the object. So the time you attain specific temperature, you need a long time. But using microwave induced pyrolysis, you can just operate in relative low temperature and attain specific temperature in a short time. But the drawback is that not all the material is suitable for microwave-induced pyrolysis. So it's also an advantage. So we can use the selective pyrolysis feature. For example, in the carbon fiber composite waste, the carbon fiber is a very strong microwave absorbing material, so we can create a very high temperature around the surface of the carbon fiber. So we can degrade the resin in the carbon fiber composite waste, so degrade the resin very fast than conventional pyrolysis. So that is the advantage and the drawback of a microwave induced pyrolysis. And your second question about the adsorber, I'm not very sure because we have used a solvent in the iodide capture and also apply our solid residual from the polarizing film into the dye-containing wastewater treatment. So which solver you like to know more?
I think the one in your last slide,
Oh, my
briefly,
last
I
slide.
think, yeah, I'm sorry if I'm mistaken, but briefly I saw something about adsorbent.
Oh, the solvent. So yeah, because microwave induced paralysis could produce different type of the product, and it could be adjusted as desired if we manipulate different carrier gas of our the microwave parameter. So one of the product of the microwave paralysis is the residual. Solid residual. The solid residual could be served as the like the activated carbon adsorbent for the wastewater treatment.
Okay. Thank you very much, Professor Kwan.
Thank you.
Thank you. Okay. Do we have another questions to Professor Kwan?
I think we have a question from the chat box. Let me wait. Allow me to share the screen of the question.
Oh yeah. Okay. I can read that question
Okay.
at the same time. So we got a question like, how can microwave induced pyrolysis being implemented on a large scale if it's
Okay.
feasible to upscale this equipment?
Okay. Because in our lab we just have a lab scale instrument, but actually we have some cooperate with the vendor. They developed the commercialized scale, full scale of the instrument. So actually they have two types of the instrument for real operation. The first one is that they use just like a chamber, some like the escalator, just travel through the factory. Then there is a chamber, have the microwave radiate on the surface of the waste. So the waste can be treated through the microwave chamber. This is the first type. And the second type is that they use like just very large oven, okay? And inside the oven, they just set up several microwave emission source. So they can create in the chamber all the reaction or pyrolysis just under the microwave reaction.
So, okay.
Okay.
I just have a follow-up question like, do you know what's the scale that your vendor are designing? For example, what's the ratio of capacity for the net scale comparing to your laboratory operators?
The type one of the travel escalator to the factory, they apply the microwave induced pyrolysis into the polluted soil treatment. So they have the scale, I think maybe about 10 tons per day. And the second type is for some hard degraded waste. For example, like the polarizing film, they have I think maybe 1 tons per day.
Okay, I see. Thank you. Okay, do we have other questions? Okay. Okay.
No more question for this session, Dr. Yo, but we still have several questions unanswered. Can we go back to some questions that we haven't answered yet? Let
Yeah,
me
sure.
share.
Thank you. Thank you, Dr. Guan, for your exciting talk. And then, Irving, could you please share the screen? I mean,
Yes.
the questions that aren't answered yet.
Yep. Okay. Okay, these are the question. Have you seen the screen?
Yeah. I saw that.
Okay.
Yes. So for the question, that's from Professor Wama, and that's to Mr. Wu from Jian Company. And the question is, you showed the cleaning of your waste in the video. Your sources of the waste come from where? And is that from MSW or from industry?
Basically, we collecting the waste from the office factory industry, and it's called PIR, right? We collecting majority waste from the PIR, but we also collecting some waste from the PCR. But the purity, to talk about the purity of the raw material, I think PIR is more easier to handle. The PCR one is more difficult. Yeah.
Okay. Thank you, Mr. Wu. And another questions also goes to Mr. Wu. Like, there are a lot of waste of IT industries, such as chips, capacitors, and semiconductors, fiber optics, etc. Separate these wastes were hard for sure. For sure, need any machines or recycling process. Do the efforts still give profitable value for business compared to the cost of recycling process?
It is a tricky question to answer because most of our customers they hope we can provide total solution for them. The meaning of total solution means the difficult one, easy one, we have to handle it, and in legal way, not instead of illegal way. So the profitable, yes, the business need to profit, need profits to survive, but we do face some situation. The customer in the beginning they provide unclean and not easy to handling waste to us. So I think we can take advantage is the customer teaches us a lot. They push us to do some impossible mission to possible. That's why in my slides I introduce our aluminum plastics separation machine, which is from our customers' friendship, the pressure. So we will see to get the balance in this industry will be the final winner, I think.
Thank you. What's the next question? Let me see. Okay, the next question that goes to Dr. Huang. And in Indonesia, some local industry or local governments use pyrolysis for treating of plastic waste. What's the advantage use the pyrolysis and what's the drawbacks of mixed plastic process?
Okay. For example, for the mixed plastic, if you have like PET, nylon, and other, for example, like PVC inside your mixture, then you will have a lot of heterogeneous atoms inside the pyrolysis oil. For example, like nitrogen, oxygen, halogen in the pyrolysis oil. So nitrogen and oxygen is okay, but you need to have a hydrotreating process to remove the hydrogen, the nitrogen and oxygen. And for the PVC, we don't want to have the chlorine inside the pyrolysis oil, because during the further treatment, it will form like a acid gas, and you would typically it's not okay for the for our instrument. So we typically we will want to sort it out the PVCs.
Okay,
And
thank you.
yeah, and for the pyrolysis, of course, you still can tolerate more impurities than other recycling methods.
Yes, I think. Okay, thank you. Thank you, Dr. Huang. Okay. Excuse me, Irving, is that all the question that we got?
Yes, yes. I think we've got it all covered for the questions.
Okay, so to the audience, do you have participants? Do you have any questions that you may have?
Perhaps for Indonesian friends, can I speak in Indonesian language for a while? Perhaps some participant would like to raise question in bahasa Indonesia. Untuk peserta yang kita punya masih beberapa menit waktu, mungkin ada pertanyaan boleh disampaikan dalam bahasa Indonesia, nanti kami bantu untuk menyampaikan. Jika ada teman-teman yang bertanya dan menghendaki untuk berbicara bahasa Indonesia, silakan. Nanti akan kami bantu untuk sampaikan dalam bahasa Inggris. Monggo. I was just telling participants that if they have a question in Indonesian language, we are welcome. And then we will translate it to English. We still, I think, less than 5 minutes, Dr. Yu?
Yes, yes.
Mm.
Yes, so let me see the chat board. Okay. Okay, no more questions. Okay.
Yes, I think so.
Okay, anyway, to all the participants, if you have any questions, you can feel free to email me or email Irving, and we will try to answer your questions. Okay, so thank you all the participants to join in this webinar today, and we are having a wonderful time with our exciting presentation. Okay, so just as mentioned by Dr. Liu, Professor Liu, that this is just the beginning of the center, and we will keep continuing working on this. Okay, so before we closing the webinar, Professor Liu, do you want to say some words to us?
No.
Okay.
Dr.
Okay.
Yo, let's us take more picture before we end this webinar.
Yeah,
we
sure.
have the beginning picture, we have the end of this. So
Yeah,
for
sure.
the participant, would you please turn on your video before we close the webinar? And we hope to see you again in the next webinar that certainly we are going to have more webinar, which is very interesting topics. Boleh peserta silahkan turn on your camera, dinyalakan kameranya untuk kita berfoto sejenak sebelum kita berpisah. Dan kami berharap kita bisa berjumpa lagi di lain kesempatan untuk webinar-webinar yang berikutnya. Mbak Bila atau Mbak Dia bisa membantu ya dihitung supaya kita siap-siap. Silakan.
Okay. Thank
Wait,
you. You all.
wait, I think
Oh.
Bila kayaknya suaranya tidak terdengar.
Okay, I will count for 3, 2, 1. All right. And for the second slide, 3, 2, 1. Yeah.
Is that all, Bila? Is it finished?
Yes.
Okay, thank you. We finished taking picture, Dr. Yu.
Thank you. Thank you. Okay. So if there is no more questions, thank you again for all the participants. We would like to see you in the near future. Thank you.
Thank you. Thank you, everyone. Professor Liu, thank you very much. Professor Kwan, Mr. Wu, thank you very much.
Thank
Dr.
you.
Huang, thank you
Thank
very
you
much.
all.
Thank you.
So